Hello, this tutorial is going to be about squares and square roots. Here we have the x, which is the square, which is the radicand, yes, and we have this symbol here, which is the radical. Okay, now if we're going to take the square root of x, then it's easier if I just explain what we're talking about with these squares here. So first of all, let's say you've got 3 times 3. So that could be 3 squared, and that's going to equal 9. Okay, so if you had 3 times 3 times 3, then this would become 3. And that would then be 27. Okay, so we're just going to stick with the squares right now. But this is basically what it is. So if we had 9 that had the square root, that would equal 3, because 3 squared equals 9, and this here is just saying we want to take the square root of it. I want to point out that we can do negatives as well. Let me explain the negatives. If I have negative 3 squared, so that's negative 3 times by negative 3. Let's just do that up there. Negative 3, this little dot means times negative 3. That's going to equal 9. It's going to equal positive 9, because a negative times a negative equals a positive every single time. Yeah? If this was to the 3rd power, then that would be negative 27, because it would be negative 3 times negative 3, which is 9, and then a negative times a positive, a negative times a positive, it should be a negative 3 there, shouldn't it? Sorry, negative 3. That would equal negative 27. Okay, that's what we're doing there when we're squaring something. So if you have 4 squared, that's going to equal 16. If you have negative 5 squared, that's going to equal negative 25. So what does that mean for our radical? Well, it turns out that if you're taking the square root of anything, let's just stick to something simple like 16. You might think, well, this could be negative 4 or positive 4, because they would both equal 16. However, when we're talking about this usually, and unless it's indicated otherwise, it's called the principal square root. Yeah? And that means that it's always going to be the positive. If, however, you have something like, let's just make a little bit of space over here. If you have something that is indicated, it could be one or the other, then it would be positive or negative square root of 25. Then the answer to that would be negative 5 or positive 5. So it would always be indicated. Otherwise, it's the principal square root. So I know that you could take square roots of other numbers. Like, you know, you could have the square root of 7. And if I did that with a calculator, I don't know if my calculator will actually do it, but let's have a look. There, if I take the square root of 7, it comes up with this big answer here. If we just zoom in here, like, can you see that? Whoops, a little bit far. It comes up with that big answer there. It's just that it's got a lot of digits in it, that's all. So that's not a perfect square. For the moment, we're just going to be interested in perfect squares. And by a perfect square, I mean something like 5 squared equals 25, 6 squared equals 36, 7 squared equals 49, 10 squared equals 100, 2 squared equals 4. Yeah, these are called perfect squares. Like this is a perfect, there, 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 there. I guess because, like, you've got a square and it's 6 times 6, then you know that this bit's going to be 36. That's the square roots, the radical, the radicand. Remember that this is the radical, this is the radicand. You're going to have the square sign there, which is incidentally an exponent or an indices. It's just something times itself. This is more or less undoing this over here.
I really hope you liked my video. If you did, give it a thumbs up and come and check out my channel.